Hi, everyone. It's great to be able to kick off the last hour of the conference. This last hour is all Spring. We've got a great code demo coming up, but right now it's me. And what I want to do is take you back 45 minutes or so to Onzi's presentation and the circle of code. So just to recap, the circle of code is this. All software starts with ideas. Ideas are recorded and logged in a software system like Tracker. You then take that and develop software, hopefully using Spring. As you commit code, it's built continuously, perhaps using a CI system, perhaps Concourse. From Concourse, you deploy, perhaps to a platform, hopefully to Pivotal Cloud Foundry. And then as a result of running software, you can analyze it, you can look at metrics, and that gives you more ideas. This is circle of code. Easy if you're working on a small system. As we've heard, a bit harder if you're working on a monolith. Now, the interesting thing about the circle is, once you know about the circle, once you know about this idea of feedback loops, you kind of see them everywhere. So what I want to do is take you through some history. I want to talk about Spring from its inception in 2002, right through to the current time, 2016, and show you how circles and feedback loops have affected the project and how key decisions have been changed because of them. So let's begin at the beginning. It's 2002. So 2002, there's no Facebook, there's no Twitter, there's no iPhones, there's no Kindle, but there are books, and there's this book by Rod Johnson. So this is the first example that I could find of a circle. And the reason I put this up is because Rod's book was born out of his experience consulting. So he would go into companies, he would look at their code, he would come up with ideas, advise them, and those ideas eventually formed the genesis of this book. And more importantly for us, the source code that would eventually become Spring Framework. And the circle completed because by releasing the source code for the Spring Framework, Rod was able to get more consultancy to continue to grow the business and to provide a sustainable future for the project. Now, you've got to think what life was like in 2002. And if you were developing a system, typically it looked something like this. To begin with, you'd pay a large bunch of money to a big database vendor, and you'd get a database installed in your data center. Now, this is quite an expensive piece of kit, so you need to protect it. And to do that, you'd employ these people called DBAs. Now, DBA's job is to stop people from breaking the database, mainly by not letting them use it. It's a very lucrative time to be a big database vendor. Now, next thing you've got to do is pay another bunch of money. And this time you'd get some servers installed. These would probably be Windows servers at the time. Again, quite an expensive piece of kit, so again, you had to protect it. This time you'd employ people called sysadmins, and their job was to stop people from breaking the servers, mainly by not letting them use them. And then you had your developers. And developers' job was to take software, get it through the line of sysadmins on the servers, and through the line of DBAs to get access to the database. Now, typically a system would look something like this. Windows was the dominant operating system. People used dial-up. In fact, the average amount of time that people were online a day back in 2002 was just 45 minutes. And this was known as monohorific architecture. Now, you might think that nothing good could come out of this, but actually some good did come out of it, because what a lot of developers would do would be to take some old hardware they had lying around, some old machine under their desk, throw on some Tomcat, make use of Spring's portability, kind of duct tape it all together, and at least end up with a place where they could develop quickly, even if getting it into production took a little bit of time. Now, the second example of a circle that I could find is, I think, perhaps the most important one in the entire history of the project. And that's the fact that Spring was open source. Now, you've got to remember, in 2002, open source was not a guaranteed successful business model. In fact, a lot of people thought Spring was insane for giving away their source code. But not only did they give away their source code, they gave away documentation for free. You could access their issue tracker. You could see how the build system worked. And for a developer like myself, before I joined Spring, this was excellent. This gave me, and developers like me, a way to learn how to develop software. And ultimately, people like me could contribute back, and the circle completed. Now, in this period of time as well, we're starting to see the genesis of other Spring projects. So things like Spring Batch and Spring Integration, data and security, the ideas are starting to form around these. And again, we've got circles. We've got ideas coming out of Spring Framework, going into the projects, and then bugs and fixes going back to the framework, and sometimes even code from these sub-projects migrating back as it makes sense. OK, let's move on a bit. It's 2007. So this is the year that the iPhone was invented. This was the year that the Kindle was invented. And also, Twitter was invented in 2007. And Twitter is an interesting medium because it gives people another way to give us feedback. And in 2007, the feedback that people were giving us was, XML is not so good. Or more formally, angle brackets SSD, XML is a little bit long. So you can't take everything that's on Twitter too seriously. If you look at the people that are on Twitter, and you overlap people that actually aren't complaining, there's basically one person, and that's Spring Jürgen, and he doesn't even tweet. But, I mean, people have got a point. We're asking them to write their code in this language called Java, and then we're saying to them, you know, and write your configuration in this thing called XML. So we know we've got a problem. We have a think about it. And the solution comes with annotations. So here continues Spring's love affair with annotations. And at configuration was born. Actually, Java configuration formed the basis of a lot of things going forwards and was shipped in Spring 3. Oh, let's go back to our architecture and see how things have changed. So things are moving differently here now. We've got a lot more open source databases coming in. So people are using MySQL, using Postgres, and trying to cut down some of the costs in their databases. Sysadmins have been rebranded. They're now called operations. We've got a lot more Linux coming in on the servers. Maybe because the costs are coming down, some of the walls are starting to soften a little bit. Some people have even managed to take Tomcat from that machine under their desk and are now running it in production. And in terms of the systems, you know, people are at home, have got broadband of sorts. In terms of mobile connections, even though the iPhone was released, they're still kind of a little bit flaky and slow. And this is known as monolithic architecture. And you should probably get used to monolithic architecture because it's going to be around for a little while. OK, let's go on to 2012. So iPhones are everywhere. Everyone's got one. People have started to use .io for technical domains. And Spring is kind of doing OK. We've got these projects. We've got these users. In actual fact, we've got quite a lot more projects have come online. And that's kind of giving us more feedback loops, but also causing complexity. And some of our users are starting to get a little bit frustrated with what we're offering. And it's kind of understandable. I mean, if you've used a project like Drop Wizard or Rails, you're getting an experience that looks like this, whereas Spring's kind of giving you a bunch of high-quality ingredients, but leaving you to kind of mix them yourself. So again, we've got this problem. We've got to fix it. Now, in 2012, something else was happening, and that's that various assets from EMC, VMware, Greenplum, the database, and Pivotal Labs, an agile consultancy firm, were coming together to form a new, as yet unnamed company. Now, I don't know if you've ever tried to put together a company, but it turns out there's paperwork. A lot of paperwork. But that actually was quite a good thing for us, because it meant all the management were tied up doing company paperwork stuff, and us as engineers were just left alone. So we could get to work. What are we going to need to fix this problem? Well, the first thing we wanted to do was we wanted to have an embedded version of Tomcat. We wanted to take Tomcat and put it inside our apps, rather than taking our apps and putting them inside Tomcat. And we'd actually already done some work on this, and we had some prototype code. We'd called it Spring Embedded Tomcat. So we took that. The next thing we wanted to do was we wanted to have support for jars inside jar files, or fat jars. There are some technologies you can use, but we had some ideas for a different way of doing it. We'd already done some prototype code. We'd called it Binks. Jar, Bink. All right. And then we wanted to have metrics. We didn't have any code for this, so we set out to write something new, and we called it Spring Actuator. I still don't know why we didn't call it Spring Metrics. So we've got these component parts. We've put them together. What are we going to call this new thing? Well, the first idea we had was we're going to call it Spring Bootstrap, which is pretty good, but it sounds a bit like a CSS framework. So we then had another think, and we came up with Spring Zero. Zero config, Spring Zero's pretty good. But it does sound a bit like a soft drink. So we went back to Spring Bootstrap, and then someone in the team, and it wasn't me, someone in the team had the idea, why don't we just chop the end off Bootstrap and call it Spring Boot? So Spring Boot was born. We got the GitHub project. Everyone in the team was happy. Everything went well. Now, meanwhile, back at the paperwork, back with the company, some very well-paid brand consultant had a similar revelation. What if we took Pivotal Labs and just chopped the end off it and called our new company Pivotal? They got paid a lot of money, and Pivotal, the brand, was born. OK, so we have a new company. We have a little bit of budget. So what's the first thing we're going to do? Well, we need to get rid of spring.org and get ourselves one of those new IO domains, spring.io. And we did. We got the money. We bought the domain. Spring.io was born. And we had to think about what can we put on this domain. And we thought, well, we could just put our existing website up. It looked like this at the time. It's not bad. Except it's a WordPress site. And it's got some kind of custom PHP scripts that no one will even admit to writing. And it's got this bulletin board system that keeps getting hacked. So it's a pretty good place to go if you want to buy Viagra, but not much else. And we're kind of maintaining this thing, and it's ticking along, but no, let's build a new one. So we had to think, what are we going to use to build this thing? And it turns out we have this framework called Spring, so maybe we could use that to build it. And we have this new project we're developing called Spring Boot, so maybe we could start to use that. And who are we going to get to help us build it? Well, we have this agile consultancy company called Pivotal Labs, and they're really good at building websites. But what's more, they're really, really good at prioritizing work and making sure you build the right thing. So maybe they could help us. And where can we host this thing? Well, we have this new project called Cloud Foundry, so maybe we could host it on that. And again, this is another example of a feedback loop, another circle, one that I think was tremendously beneficial for the early days of Spring Boot. We were able to guide the project by taking the requirements that were coming from a real app, and because we were deploying to cloud platforms from the beginning, we were able to create a development process that was very cloud-friendly. And we did it. Spring.io went live in 2013, was actually switched on live at the Keynote, and Spring Boot, like an early preview release, 0.5, was released in the same year. And our developers and users have now got a they've still got access to all that individual ecosystem, but they've got a more logical way to consume it. And people are happy, mostly. There's always one person who's not happy with free software. Now, we kind of expected that Spring Boot would work well with Pivotal Cloud Foundry. Obviously, we're on the same company. We developed it that way. But what we weren't expecting was that so many other companies would start to adopt and suggest Spring Boot as a way of running Java on their platforms. So all of these logos that you see here have either written about Spring Boot or gone to conference and done demonstrations featuring Spring Boot. We also weren't expecting that people would start to build on Spring Boot. So if you're using the new version of Grails, that's a Spring Boot application. If you're using JHipster, it's a generator that will create Angular, and it generates Spring Boot Angular applications. And if you're using Spring Cloud, that builds on concepts that the foundations are in Spring Boot. Now, I'd like to focus on Spring Cloud just a little bit more, and specifically I want to talk about its relationship with Netflix. Now, Netflix have already had this cycle with the cloud. They were an early adopter of Amazon. They decided to run all their infrastructure on Amazon services. And again, at the time, people thought they were insane not having control of their own infrastructure. But it worked out very well for them. And it actually worked out very well for us as developers because it gave birth to Netflix OSS. And our developers are starting to eye up this cloud thing and thinking about it. And you've got to remember that at the time, they kind of promised something that looks like this. What they're finding with the cloud is it's more like this. They kind of have to lash a lot of things together, and it's not so great. So as a team, we're thinking about this problem, and Spring Cloud is born. And another example of feedback loops, because here we've got members of the Spring team working on Netflix OSS and able to contribute issues and fixes back to that project. And because Spring is now getting the Netflix open source in the hands of our users, they're also able to contribute issues and fixes. OK, let's move forward. It's 2016 today. Let's have a quick look at how our architecture diagram has changed. The first thing that someone has discovered is by simply dropping 2 pizzas into any organization, teams will form around them. And this is called DevOps. The reason that DevOps actually needs to exist is because things have got more complicated. So if you look at the data side, we have much more choice now, many different types of data store technologies, in-memory databases, document databases, graph databases. And the same on the server side. You've got cloud, you've got containers, you've got different OSs, you've got hybrid solutions. It's really a very lucrative time to be an infrastructure provider. And then the systems that we're using, people have got tablets, they've got laptops, they've got phones, they've got watches. everything's on, everything's got a fast connection. They expect no downtime. They expect push notifications. And even things like your washing machine are starting to get connected, and we've got the Internet of Things coming on as well. And the best way we found to deal with this is microservice architectures. And if you go to lots of talks at this conference today, you'll hear about how to develop microservices. Now, something else that's interesting about this diagram, something that's different from 2002, is that open source is everywhere. Open source is everywhere. It's on the databases, it's on your servers, it's in your devices. Open source has won. And the reason that open source has won is because it's the ultimate example of a feedback loop. People from all over the world are able to contribute issues, but more importantly, they're able to contribute code. And Spring, we've been taking code contributions, from the very beginning. And if you look at just the top 6 Spring projects, in total there are 15,000 forks. We've dealt with over 4,600 pull requests, and over 670 people have contributed code that's made it into the mainline. So here's just a snapshot of some of those people that have contributed code. And on behalf of the team, I just really want to say thank you to everyone that contributes, because without people contributing, we wouldn't be able to have the Spring Framework. Without the Spring Framework, we wouldn't have the Spring projects. Without the Spring projects, we wouldn't be able to have Spring Boot. Without Spring Boot, we wouldn't have Spring Cloud, and we wouldn't be able to have a commercial offering around Spring Cloud. Without Spring Cloud, we couldn't hold a platform conference. And without a platform conference, we wouldn't be able to meet everyone who uses and contributes to our projects. So thank you very much.